Hello, viewers. In today's session, we are going to discuss another important problem from domain of functions. And here we are to find the domain of this function, that is f of x is equal to square root of 1 plus natural log of 1 minus x, right? So let us see how we can find out the domain of this function f of x using some concepts from a logarithmic function. So now see, we have to find all the valid values of x for which this function f of x is defined, right? So the first thing here we have to keep in mind that square root of 1 plus natural log of 1 minus x, right? So this term inside the square root sign must be greater than or equal to 0. So the first condition is that 1 plus natural log of 1 minus x should be greater than or equal to 0, because we cannot have this term as a negative term, because the square roots of negative numbers are not defined on the set of real numbers, right? So this term 1 plus natural log of 1 minus x has to be greater than 0 or equal to 0. And the second condition is that this term, because 1 minus here we have natural log of 1 minus x, therefore in order to define the term natural log of 1 minus x, this term, that is 1 minus x, has to be greater than 0, right? And here it is quite evident that x cannot be equal to 1, because when x tends to 1, then natural log of 1 minus x tends to natural log of 0, right? And natural log of 0, it tends to minus infinity. So here we cannot take x is equal to 1, and here we should have 1 minus x greater than 0. So we have minus x greater than minus 1, and here in order to get rid of these two negative signs, we have to multiply this inequality both sides by negative 1. So the direction of the inequality gets reversed. So we have x less than 1, and x less than 1 implies that x should belongs to this interval, that is minus infinity to 1, right? So here in order to get the domain of this function f of x, we have to take care of these two conditions. So 1 plus natural log of 1 minus x should be greater than or equal to 0, and here 1 minus x should be greater than 0. So here x belongs to this interval, that is minus infinity to 1. So here we have the real number line, minus infinity to plus infinity, and here we have 1, right? So let us represent this interval on this real number line. So here we have this region, that is from minus infinity to 1, and remember here 1 is not included. So now let us solve this inequality. So here we can now write natural log of 1 minus x is greater than or equal to minus 1, and now here we have natural log. So what we will do in order to solve this inequality in for x, will raise these two quantities to the power of e, that is we'll take e raised to natural log of 1 minus x, and here we have minus 1, so we have e raised to minus 1. So here we have used this concept, that is a log of say x to the base a, where a is greater than 1, then this function is an increasing function, right? And here when this function is an increasing function, then the direction of the inequality it remains the same, right? So now here e raised to natural log of 1 minus x is simply 1 minus x, because we know that e raised to natural log of p is equal to p, and here p is 1 minus x, and here we have e raised to minus 1, that is 1 over e. So here we can now write minus x greater than or equal to 1 over e minus 1, and again multiplying both sides by negative 1, we have x, and then we have here the direction of the inequality get reversed, and we have 1 minus 1 over e. So we have x less than or equal to e minus 1 over e. So now let us find out the value of e minus 1 over e. So we'll find out the approximate value of this expression, right? Because here we have x less than or equal to e minus 1 over e. Now we know that e lies between 2 and 3, and the approximate value of e is 2.718, right? So if we substitute this value of e in this expression, we have 2.718 minus 1 over 2.718. So now if we calculate this expression, then e minus 1 over e is approximately equal to 0.6322, right? So here x less than or equal to e minus 1 over e may be written as x less than or equal to 0.6322. So now the solution of this inequality is given by this interval, that is x belongs to the interval that is minus infinity to e minus 1 over e, and here we have closed, right? This is the closed interval, and it is open from the left and closed from the right, and e minus 1 over e is approximately equal to 0.6322. So we can now write minus infinity, and here we have 0.6322, and from this real number line, here we have say 0, and 0.6322, it lies somewhere here, right? So this point is e minus 1 over e, right? So the solution of this inequality is now given by this region, right? And here obviously this point is included. So here we have the solution of two inequalities, that is here x less than 1 is given by minus infinity to 1, and x less than or equal to e minus 1 over e is given by minus infinity to 0.6322. So now let us find out the common region, right? So now we have to identify the common region between these two intervals, that is from minus infinity to 1 and minus infinity to 0.6322. And from this real number line, we can easily see that the common region is given by this region, right? So here we cannot take the region from e minus 1 over e to 1, so only this part, right? So from minus infinity to e minus 1 over e is the common region between these two intervals. So the domain of this function f of x is now given by this interval, that is from minus infinity to e minus 1 over e, or we can also express the domain by this inequality, that is x less than or equal to e minus 1 over e. So this is the required domain of this function f of x.